Example 4, solve the triangle. Round to 2 places after the decimal point if necessary. Here, side length A is 4, the length of side B is 5, and angle A measures 48 degrees. All right, so let's go ahead and draw a sketch of this. Again, it does not need to be exact. So I'm going to go ahead and start out by drawing my horizontal. So let's see here. I'll put it like this. Okay. And I only know one of the angles here. I know that angle A is 48 degrees. So when I draw this triangle, I'm going to try to eyeball a 48-degree angle. So here I go. Let's see, it's about, let's say, maybe about here. Okay, so just over a 45-degree angle. Okay, so I'll go ahead and say this is angle A. It measures 48 degrees. Okay, and then I'll go ahead and just draw in a third side here. Okay, we know that if we go across, straight across from angle A, this is going to be side A, and that length is given. This is going to be 4 units long. Okay, and then the other information that we're told information about side length B. All right, so we just need to pick a side. So I'll just pick this side. This is going to be side length B. It's 5. So across from side length B, this is going to be angle B right here. Okay, that means the remaining angle has to be C. And then across from angle C, this is going to be side length C. Okay, all right, so here we are looking for side length C. We are looking for angle C's measure. And then we are also looking for the measure of angle B. Okay, those are our unknowns, and that's what we've got to figure out, those 3 components of the triangle in order to solve this triangle. Okay, let's first identify the case that we have been given here. So if you look at this again, I've got side, and then I've got side, and then I've got angle. So this is a side angle case. So this is the ambiguous case. Okay, so I'm going to go ahead and tell you, because remember, in the ambiguous case, you either have no triangle, exactly 1 triangle, or 2 triangles. In example 3, we saw the instance of no triangle being formed. If you scroll down, you're going to see that this is going to be the case with 2 different triangles. Okay, so I'm just giving you a heads up. You're going to see how this plays out and how you can tell whether you're getting 1 or 2 triangles. Okay, all right. This at the bottom is kind of a fill in the blank method for keeping track of the components of each triangle. So I'm going to go ahead and fill in with what we know. Okay, again, I haven't talked about how you know there are 2 triangles yet, but when it comes time, you'll see. I'm going to go ahead and fill out the information I've been given. For both triangles, side A is going to measure 4 units. Okay, for both triangles, side length B is 5 units. Okay, and also with the given information, angle A is going to be 48 degrees. Okay, that has to be the same in both triangles. Okay, that given information cannot change. Okay, but you're going to see, based on this criteria, the remaining components, angle C, angle B, and side length C, they can vary to form 2 different triangles. Okay, so let's get started to see how you can tell that there are 2 triangles here. Okay, all right, we are going to start off pretending like we didn't know that there are going to be 2 triangles. Okay, what would you do? Well, you're going to start trying to solve for something. Okay, so when you look at the given information, you're going to ask yourself, okay, what's the easiest thing to solve for here? Okay, well, we know everything about A. We know the measure of angle A, we know side length A, and so we can go ahead and set up, this is going to be law of sines because it's the ambiguous case. We can go ahead and set up a ratio here using A. Okay, so we're going to have the sine of A over A has to equal the sine of one of the other angles over the corresponding side length. Okay, the question is, do we use B or C? Okay, the answer is we need to use B to start with because we're given information about B. Okay, we don't know the measure of angle B, but we know side length B. Okay, we don't know anything about C, so if we had used sine of C over C here, we'd end up with more than one unknown. All right, so I'm going to plug in B here. Okay, this is going to tell us that the sine of 48 degrees over 4 is equal to the sine of B, that's our unknown, the angle B, over side length B, which is 5. Okay, so we're going to try to solve for B, okay, or angle B. All right, so we've got one fraction equal to another, so we are going to cross multiply here. This is going to tell us that 4 times the sine of B is equal to 5 times the sine of 48 degrees. Okay, to solve for angle B, we're going to first divide both sides by 4. Okay, so on the left side, the 4's will cancel. Okay, and so I'm going to go ahead and kind of compute this decimal for you. Okay, it's actually going to be important, so that's why I am computing it. I'm going to go to the calculator and I'm going to do 5 times the sine of 48 degrees divided by 4. Okay, so make sure your calculator is in degree mode. So we've got 5 times the sine of 48 degrees divided by 4. Okay, so I'm going to go ahead and jot down this decimal. So 0.9289310318. Okay, so if we want angle B, okay, we know that B is kind of tracked by the sine. So to undo the sine, we're going to take the sine inverse of both sides. So we're going to get that the sine inverse of the sine of B has to equal whatever you do to one side, you have to do to the other. So it's going to equal the sine inverse of this quantity, okay, this entire decimal. And that's going to give us angle B. Okay, so on the left side, the sine inverse and the sine will cancel, and it's going to give us angle B. Okay, so angle B is going to be, we're just going to go and compute this in the calculator. We're going to take the sine inverse of this decimal. And again, I can do second negative sign, okay, and that will pop up the previous decimal. Again, if you don't like this, just go ahead and type in all the digits for accuracy, okay? All right, so this is going to be angle B. This is what we get. I'm going to go ahead and write down this entire decimal. Okay, so this is going to be 68.26879.086, I believe. Yes. All right, so here we go, and that's in degrees. Okay, so that is the measure of angle B here. Okay, I'm going to go ahead and put it here. I'm going to round it to 2 decimal places. So this is going to be 68.27 degrees. Okay, so I'm going to go ahead and kind of jot this down. This is what angle B is, approximately 68.27 degrees. Okay, I'm going to come here and fill this in triangle 1. Okay, because we haven't even talked about a second triangle yet. So angle B is 68.27 degrees. Okay, now at this point, since you shouldn't even be aware of a second triangle at this point, I am going to go ahead and compute the third angle here, C1. Okay, so C1 is just angle C in the first triangle. Okay, we know angle A at this point, and we know angle B at this point. These guys need to add to 180 degrees, so we can go ahead and find the measure of angle C here. Okay, so we're going to take 180, we're going to subtract 48 degrees, and we're going to subtract 68.27. Well, let's see here. We probably should keep all the digits in case we are going to need to use it to compute length C. Okay, so we're going to go, I'm going to just put C 68 point dot 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 dot. Okay, so let's go to our calculator and do this. So we're going to have 180 minus 48 minus this quantity, this 68.26879.086 number. Okay, this is going to be the measure of angle C. Okay, so I'm going to go ahead and jot this down. So angle C here is going to be 63.73120914. Okay, we are going to need that decimal expansion, the full decimal expansion. We need it for the accuracy when finding side C. Okay, so as far as filling in the blank here, I'll go ahead and round this angle to 2 places after the decimal point. This is going to be 63.73 degrees. Okay, so those are all the angles in the first triangle. All right, so now I want to talk about, at this point, why you know there is a second triangle. Okay, all right, so look at going back over what we did to compute angle B. Okay, we took the given information, we applied the law of sines, we did sine A over A equals sine B over B, and we went through the process and we were able to solve for angle B. Okay, we got the 68.27 degrees approximately. Okay, here is what I want to talk about. Okay, at this step of the game, okay, when we did this process, we found that the sine of angle B is equal to this 0.92893103118 number. Okay, all right, so think about what that statement is telling us. Okay, this angle B, the sine, is this number. Okay, so if you were to look at this angle on the unit circle, okay, you would know its y coordinate. Okay, so what I'm going to do here is pretend like this is just for illustration. It's not like, well, it's just kind of explaining why there's a second triangle, I guess. Okay, say this is the unit circle. Okay, we just found that this angle B is approximately 68 degrees. Okay, so if I had to draw that in here, I'm just going to eyeball a 68 degree angle here. It's going to look something like this, potentially. Okay, so I'm going to go ahead and say here, this angle right here is like 68.27 degrees. Okay, so this point on the unit circle, okay, we don't know its x coordinate, but we surely know its y coordinate is this 0.92893 blah 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 number. Okay, because we know the sine of this angle is this decimal. Okay, and it keeps going. Okay, now when you think about this, okay, this is not the only angle that has this sine value. Okay, if I were to draw in this angle, remember the sine value is determined by the y coordinate. Okay, so if I just kind of eyeball this and I look at this particular angle, okay, this angle right here, so this red angle, is also going to have the same sine value. In quadrant 2, you're going to have positive y coordinates. Okay, again, for this red dot, we don't know what the x value is, but it's at the same height as the blue dot, so it's going to have the same sine value or the same y coordinate. Okay, so what happens here is for angle B, we know its sine value has to be 0.92 blah blah blah. Okay, so the point here is the blue angle works, okay, but so does this red angle. Okay, that opens us up to a second possibility for angle B, because the sine of B has to be 0.92 blah 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 blah. Okay, well, how do we figure out what this red angle is? Okay, well, this is what you do. Okay, what I'm going to do here, if you notice, if I make a right triangle out of this, okay, so if I'm doing this, okay, so I'm looking at, let's see here, I'm looking at this particular right triangle right here, okay, the way I've drawn this, okay, and then I'm going to make a right triangle out of the red dot here. Okay, so if I'm drawing down here like this, this is another right triangle. Okay, so I'll color this one blue maybe. Okay, you're going to see that these two triangles are congruent. Okay, so like the angles match up. Okay, so like the right angles match up. This angle is equivalent to this angle. Okay, this side is the same as this side. This side's the same as this side. This side's the same as this side. They are congruent triangles. Okay, so what that means is that this angle right here, see where I'm shading it in? Okay, that angle is the same measure as this angle right here. Okay, so this angle right here, okay, measures the 68.27 degrees. Okay, so this angle in the blue triangle, okay, if you add it to this red angle, okay, they have to form 180 degrees or a straight angle. Okay, so the measure of the red angle, okay, so I'm going to put measure of the red angle is 180 degrees minus 68.27, and I'm just approximating here. Okay, so this other angle, 180 degrees minus 68.27, the red angle is 111.73 degrees. Okay, all right, so that's what this is. Okay, as an approximation here. Okay, that's that red angle. Okay, so this is the potential for the other angle B in a second triangle. Okay, all right, so here I'm going to come down here. Okay, starting to talk about a second triangle here. You cannot change what angle A is. Okay, it's stuck at 48. Okay, but the potential for angle B is going to be 180 degrees minus that 68 number. Okay, so again, that was 68.26879086 degrees. Okay, and again, I'm just leaving all the digits for accuracy for the sides here. Okay, so if I go back to the calculator, okay, and I punch this in, and I'm doing this for accuracy, like I said, here is what we would get. Okay, we already know the rounded answer, but this is 111.73. Let's see, 12091. Okay, so I'm going to go ahead and round this for 111.73 degrees. Okay, let me emphasize at this point, this is a potential angle. It may not work. You've got to check one more thing to see if there actually is a second triangle. Okay, if there is a second triangle, okay, you've got to check on angle C. Okay, is it going to be sensible? Okay, meaning if this is angle B's measure and angle A measures 48, is there still something left out of the total 180 degrees to make angle C? Okay, so we need to see if any angle measurement is left. So we need to take 180, subtract out angle A, and now subtract out angle C, which I'm just going to call up the previous answer here. Okay, and I'm subtracting out angle B. I misspoke. Okay, so this is 180 minus angle A minus angle B, and that tells us here's the measure of angle C. Okay, it's going to be small, but it can potentially work here. Okay, so here we go. Okay, so I'm going to go ahead and write this down. Okay, so this is the measure of angle B. Okay, so I'm going to go ahead and write C down. Okay, it's 20.26879 086. Okay, again, I'm keeping these digits because when we go back and try to figure out side links, we're going to need them. Okay, all right, so I'm going to go ahead and round angle C to 20.27. Okay, that's in degrees. Okay, that's the angle there. Okay, these guys add to 180 as well. Okay, all right, so there are that confirmed. Okay, say you had taken angle A and angle B and added them together, and those two, that sum was bigger than 180, then there wouldn't be enough to go around out of the 180 degrees for an angle C. So there wouldn't be a second triangle. Okay, all right, so we've got our angles for both triangles. Okay, The only thing left is we need to compute the side lengths. Okay, so we're going to have to concentrate triangle by triangle, okay, and figure out what that remaining side C is going to be. Okay, all right, so I'm going to return to triangle 1 at this point. Okay, we've got everything written down except for the measure of side length C. Okay, so we're going to go ahead and make another ratio here. Okay, I'm going to go ahead. It doesn't matter if you use, well, I'd say here to compute side length C, I'm going to go ahead and use the original information. I have everything about angle A, okay, or A. I have angle A and side length A. They're exact values, so I'm going to use that here. So I'm going to go ahead and put here, this is for triangle 1, okay. I'm going to use sine of A over A, okay, has to equal the sine of C over C, okay. We want to plug in exact values so we get an accurate measure here. So this is going to be the sine of 48 degrees. That's the measure of angle A, okay, over side length A is 4, okay. That's got to equal the sine of C, okay. Now, out of the C values, I want to use the exact value here, okay. So down here with all the digits, okay. So the sine of 63.73 120914, okay, over C, okay. This is going to give me an exact value of side length C, okay. All right, so here we go. We need to cross multiply, okay. This is going to tell us that, let's see, C times the sine of 48 degrees is equal to 4 times the sine of 63.73120914. Okay, if you want C, you need to divide both sides by the sine of 48 degrees. Okay, so then on the left, these guys cancel. Okay, and so this is what we need to punch into the calculator. Okay, all right, so let me see here if I can scroll this over so we can see it. Okay, I'm going to do 4 times the sine of 63.73120914 divided by the sine of 48. Okay, so there's your value for side length C in the first triangle. Okay, so I'm going to go ahead and try to write this down. So this is going to be, I will go ahead and just round this. Okay, this is good. If I round it to 2 decimal places, this is going to be 4.83. Okay, all right, so 4.83. Okay, whatever length, whatever units length is measured in. Okay, all right, so we have all the components for triangle 1. Okay, and then I'm going to go ahead and do the same thing for triangle 2. Okay, we have all the components. We are just missing side length C. Okay, so again, I'm going to make the same ratio. Okay, I'm going to do sine of A over A is equal to sine of C over C. Okay, it's preferable to use A because you have exact values here. You don't for angle B. Okay, so we're going to have the sine of 48 degrees over 4 is equal to the sine of 20.26879.086 degrees divided by C. Okay, and this is C2. Okay, I'm just saying this is the C value in the second triangle. Okay, all right, so we're going to cross multiply here. Okay, so we're going to get that C2 times the sine of 48 degrees is equal to 4 times the sine of this 20.26879.086 number. Okay, divide both sides by the sine of 48 degrees. Okay, and that is going to give us our C2 value. Okay, these guys will cancel. Okay, I'm going to plop this into the calculator. Okay, so this time it's going to be 4 times the sine of 20.26879.086 divided by the sine of 48 degrees. Okay, Here comes the C value for the second triangle. Okay, I'm just going to go ahead and round this to 2 places after the decimal point, so that's going to be a length of 1.86 units. Okay. All right, so in doing all of this, okay, balancing both triangles, it is difficult to kind of visualize how this works, okay? So I've gone ahead and drawn both triangles out for you, okay? So you can see how they compare. Remember, in both triangles, length A has to be 4, length B has to be 5, angle A has to be 48 degrees, okay? It's length C, angle B, and angle C that are varying between the two triangles, okay? So if you go to page 6 of the notes, okay, under example 4, side angle, 2 triangles here, you can see the 2 different triangles, okay? In both triangles, I have an angle of 48 degrees. Angle A is 48 degrees, okay? That's this angle, okay? And then what you see is the side length across from angle A, okay? That's side length A, okay? It's 4 units long, okay? These 2 side lengths are the same size in both triangles. I drew these to scale, okay? So these 2 yellow lengths should be exactly the same, okay? Both triangles have side length B matching up. These blue lengths should be the same in both triangles, okay? But you can see the angles are differing, okay? Angle in triangle 1, angle B is about 68.27 degrees. Angle C is about 63.73 degrees, okay? And then you've got side length C being about 4.83 units in length, okay? And then you can see in triangle 2, angle B is obtuse. It's about 111.73 degrees. Angle C is extremely acute. It is 20.27 degrees, and that remaining side length is about 1.86 units in length. Okay, so that's pretty cool that you have 3 of the components of the triangle that are fixed, but in the other 3 components vary to form 2 different triangles.